definitely ready now. Okay. So, basic probability theory. So we set the stage last time for probability theory because we talked about sets and set theory and set intersections and set unions and I don't know what else. Set complements. And we had good puns. How we laughed. It's great. So now we're ready for basic probability theory. The sample space, omega, of an experiment is the set representing all possible outcomes of the experiment. Okay? So we're going to take a real simple example first. If a coin is flipped, so that's our experiment, we flip a coin. The sample space is omega equals the set of either heads or tails. Those are the two possibilities. Those are the two possible outcomes of the experiment. Either it comes out heads or it comes out tails. If a coin is flipped twice, the sample space could be, I had to restart my computer. Sample space could be the set containing the outcome heads and heads, heads and tails, tails and heads, or, you guessed it, tails and tails. I thought it would be cool to combine the tops of those two T's, but now it just looks like a capital pi. So, however, the same experiment can have different sample spaces. For instance, for two coin flips, we could also choose, you guys are like, what other possibilities are there? But here are other possibilities. So, one event could be the flips are the same. And the other one could be the flips are, you guessed it, different. We base our choice of omega on the problem at hand. So maybe we care about like evenness or oddity of a roll of the dice, or maybe we care about the sum of the numbers, or maybe we care about what each individual one came out to be numerically, or maybe in this case we care about if they're the same or they're different. Like there are a lot of different possibilities for a given experiment, but the sample space can be constructed. I mean, you can't just choose anything. Obviously, there are some things that are excluded. Like for instance, the flips can't be the same and different. That would be excluded as possible. Or maybe it shows up on its edge, and in which case it's neither. Okay. Maybe. Brianna knows what I'm talking about. So it might seem like I'm picking on Brianna, but also I learned the pronunciation of her name recently, and I try to do that thing where if I have a hard time pronouncing somebody's name, I just say it a lot because it helps me. So thank you, Brianna, for allowing me to continue to repeat your name to help me remember. Because when I read it, I want to use the other pronunciation, which I shall not use now. Otherwise, I could really screw up the pathway in my brain to the right one. So, an event, okay? You guys might have thought you knew what it was, but you did not. An event is a subset of the sample space. That is, an event excuse me, corresponds to a yes or no question about the experiment. For instance, event A, remember, A is a subset of omega, in the coin flipping experiment, 2 flips might be that it's either heads, tails, or tails, heads. That's an event. A is an event that corresponds to the question, is the second flip different than the first? So that would be a question you could ask. A is the event for which the answer is yes. So that's how we can think of an event. An event is an event in the sort of typical use of the word, right? Like something that occurs. It's an event. All right. Algebra of events. Consider a toss of a single die. We choose the sample space to be 1 through 6 as the possibilities. So like those are all the possibilities when you cast a die. And yes, you might be curious about
6-sided one, right?
No, just yes, 6-sided die. Just a 6-sided die, not one of those weird diamond ones. We don't like those. Those are too many possibilities. Too much math. We don't like math in this class.
Says you can't use those for craps.
So, okay, 1 through 6. It's a die if it's one of them. It's dice if there are multiple. Plural, dice. Die is one. I know. Let the following define events. A is the event that the result is even, which is equivalent to the result being 2, 4, or 6. B is the event the result is greater than 2, which is equivalent to the event 3, 4, 5, 6. Find the following event combinations. Okay? So A union B, A intersect B, A minus B, B minus A complement minus B. Whew. Okay? Go. Also, give me an interpretation of it, too. Like, what does it mean? In words. This is your first pop quiz. It's worth a grade.
Really?
No, I'm kidding.
I was like, wait, what?
I should do that, though. That would be fun.
No, that was mean.
There's 2 events there. Right?
2 events. So, but we're going to consider these different possible combinations of events, because we can because there's sets. These 2 events are sets, so we can just manipulate them as sets, and then we can interpret them to mean different things in terms of the event. So we'll do the first one together, and then I'll set you guys free to do the other one. So how would you compute, first off, A union B? How would you compute it?
You just combine them.
Without repeating.
So we can pretty much, when we do union, we want all of the ones, so we want something that's in one. If it shows up in at least one of them, you include it, right? So we're going to count 2, 3, 4, 5, 6, right? No repeating. So in words, I would say this would mean that the event is even, which is what A is, right? So A is the event that the result is even. And B is the result is greater than 2. So what I would say A union B is even or greater than 2. So I want you guys to try the intersection one now. I'll walk around and harass you.
Use A.
Yeah, A is even, so 2, 4, 6.
No, but the
My family is I don't know. Like my mom was really into it, kind of also into it. My sister has like a degree in math. I don't know, so cool. Nutrition. Like a nutrition school. Yeah, right? I know. I'm like, I don't know.
Did you buy that jade egg from Planet Ultra? The jade egg? Yeah. If you did, just Google that out.
Like has these weird parties where everybody comes. It's just a bunch of natural diets.
But like, if I got invited,
I feel like it would be that fun.
I'm all for natural remedies, but I think some people take it like way too easy.
right? Well, what bugs me is when it's like they don't recognize the limitations of it, when they're like, there's no science that proves this is not gonna work, and you say yes, but like that's true of a lot of things, and that's also not evidence that something is the case. But
That's what my grandpa used to always tell me, like, they'd be out working in the field, you know, like, and they'd get a cut or whatever.
Yeah.
They didn't have, like, they lived so far away from everything that they would just take, like, gasoline or, like, diesel, like, whatever they had in the trailer, and, like, pour it on their cut. And it would keep it from, like, getting infected and, like, take all the sewer and stuff. And I'm like, that's probably not the best thing. He's like, but it worked.
yeah.
What else are they gonna do?
Yeah, I mean, if you have like anecdotal evidence, like it's really like we glom on to anecdotal evidence so easily. I don't know. We're actually just like not very smart. Like just in general, we're bad at being smart. Is what it comes down to.
So this is
Okay, so then.
minus A minus B.
So that would be 4.6.
I like what I'm hearing out there. People are getting ahead of the game here. So what's the intersection? 4 and 6. Stuff that shows up in both, right? So even and greater than 2 is the interpretation.
Wait, why did it have to be greater than 2?
Because B is the result is greater than 2.
Okay.
So it has to be both if we want it to be in the intersection. So even and greater than 2. What's the third one?
2.
We need to do A minus B, right? Set minus B. So we need to take A, and the way I just do it is I just take A and whatever shows up also in B, I take it away. So 2 doesn't show up in B, so we have that, but 4 and 6 both show up in B. So we're left with just 2. And in my head, I dramatically say, "Take them away!" if they show up on the other one.
New Testament.
Yes, the Sanhedrin. We have a biblical scholar in the group. Huh. Very cool.
Sadducee or Pharisee? That is the question.
I grew up in an evangelical church. I know you could probably tell. Even but greater than, or no, even but not greater than 2. And
Can we just say
Yeah, just equal to 2.
yeah, well, so it's just 2. But the reason I say but not greater than 2 is you take A and then you subtract everything that's greater than 2. So it's even, but anything that's greater than 2 we're going to take away. So that, I mean, you could,
so the not statement is important at the end.
yeah, but you could say even but less than 3 would be another way to say it, or even but less than or equal to 2. You could also say result is 2. I mean, so I think that what we're going for is like an interpretation of these 2 events together, being combined in these different ways. So that's why, I mean, they're all correct in a sense, but yeah, it's just trying to get like a good understanding of sort of like the intuitive side of it. And so then we do B minus A. So I grew up in this evangelical church, and there was a youth pastor that I had who made songs up, and they still are in my head to this day. What? Little jingles. Little jingles in my head. So, for instance,
This little light of mine.
oh well, I mean, but that was more famous. But there was one song where you said, "I don't want to be a Sadducee, because the Sadducee is sad, you see.
Yep. I'm gonna.
I don't want to be a Sadducee."
No.
Was it possibly a song called "I Just Want to Be a Sheep"?
Bah. Yes. Maybe he didn't even make them up. He was also a plagiarist. Turns out.
Yeah, that reminds me.
You should sue him.
He wrote them out on overhead, like in marker. I feel like they're still gonna be in my head though, for the rest of my life.
What's his name?
Oh God, I don't even know.
That's way back in the day.
We had to call him Sir Elton John. No, I don't know. I really don't know. But in any case, he was a liar. So B minus A. 3, 5, no 4, no 6, right? Three, 5, and I would say greater than 2 and odd would be one way to say it. And, I like nonchalant can do ampersand now. And odd. Five. You know, the first time I encountered, I'm just like telling stories today. First time I encountered the plus and symbol that I used, that like I don't even know if it's really a thing, but this
Oh, I do that.
for and, yeah, it's just really nice. It's easier than plus, but like also seems like it means and easier than ampersand, which is kind of hard, but I'm good at it now. Not that good. I mean, like my upper loop is too big, but you know where I learned this little and?
Is it the guy who taught you those songs?
No, I actually remember. I remember. It was when I was in first grade and I was at lunch.
You can remember first grade?
Parts of first grade. I opened up my lunch. My mom had packed for me, and she'd written me a note, and it included this symbol and I was like, learn a new thing every day. And now but now I'm moving to ampersand because I'm cutting my ties.
You see, the only thing I remember from first grade was this kid yelled at me on the playground because I didn't know how to play kickball.
Really?
Yeah, that's the only thing I remember about first grade.
I thought it'd be like first
Man.
without nap time.
That's like pretty harsh for first grade, man.
Yeah, he was like, he was in second grade. He can't wall ball. You can't play wall ball.
So and is that part of our notes?
Yes.
Sure.
Yeah,
I'm not bitter.
I got made fun of a lot for my name when I was in first grade.
I was barely learning.
Because you didn't look like Uncle Rico from Point Dynamite.
Yeah, that wasn't out yet, but yeah.
And I was like, I don't know how to write.
I don't really know what the reasoning was. You know, people don't need a reason to make fun of you.
They're kind of the
There's
nicest
usually never.
I mean, they make fun of people, and they don't even. They're still innocent because they have no idea what they're doing.
Yeah,
Yeah.
first graders, man, they don't even like dress themselves yet. Like, I mean, they're pretty limited, but they still make fun of other people. All right, so A complement minus B. Okay.
Wait, so is it 1? Or is it
Is it 4 and 6?
So it's A complement. Let's write it out because A was even, right? So complement means it has to be odd.
1,
So
3, 5?
1, 3, 5,
Okay.
and then minus B, which was
3, 4, 5.
3, 4, 5,
Sweet.
6.
Yeah, where did that one come from?
Because the set is omega, not B. Like the set is omega and
Right.
since A is all even, all the odds from omega come out into the A bar.
I thought it was complement B.
The way the notes are phrased are weird, but the actual set is omega inside of his example here.
So
complement is based on the entire set.
yeah. So complement is always so A is a subset of omega. Aren't you glad we went through this, right?
Crushing them out of the park today.
Yeah. So the result is just 1. And the way we would interpret this in words would be, so this would be not even, or
And not
you could
greater
say
than
odd.
2.
Yeah, so not even and, my mom's version of and, not greater than 2.
Dang it, Jordan. The result is 1.
I like that one the best. Just resulted.
Okay. So, I mean, at events, the idea is we can manipulate them as sets, and we can create other events from previous events, right? We can mash them together. We can talk about how they are related to each other. The event class F is often defined as the set of all subsets of omega. It's actually more complicated, but we'll ignore that. So this should be like not the, yeah, this should be that F. Is the set of all possible events given a sample space omega. When referring to an event, we often state that it is an element of F. Oh, it looks like I was actually wrong in the first one. My bad. They should all be the script one. The first one is,
Because there are
Weird.
more of the other one than there are of the first.
yeah, the difference in LaTeX is math BB for this one and math cal for the other one. They both start with math, sir.
Yeah, but then you have to go to the other side of the keyboard to get to the other choice.
Also, they have nothing to do with F.
True.
Yeah, that's the worst part.
You haven't convinced me yet.
I try really hard to make you guys nice notes, and all you do is complain. All right. So F is the set of all possible events. When referring to an event, we often state that it is an element of F. For instance, we might say A is an element of F. Okay, I didn't give you guys like a for instance, but let's do a quick for instance. Let's take a simple. Let's take a. Can we have? We can only have a 4-side. 4 sides is the fewest number you can have on a die. You can't have a 3-sided, can you?
Actually, yes, you can have
Yeah.
a 3-sided.
You can?
Yes.
If it's curved.
No, it,
Flat edges, flat
It would just be
surfaces.
It's kind of like that.
Yeah.
So that when
Oh.
one side lands up, you see 3.
Oh, I see.
Two.
I see. Gotcha.
Or then you could do a coin or a
Let's
ball,
do
which
three.
would
Let's
be
do a
one
3-sided
side.
die then. Let's do a 3-sided die. So you have 1, 2, and 3 as possibilities. Then the event class would be the set of all subsets. So, for instance, 1. For instance, 1, 2. For instance, 1, 2, 3. And another one, I'm not going to do all of them, would be like a 2 and a 2, etc. So I won't close it. But it's also known as the power set. Oh, I can't use 2 and a 2. 2 and a 3. It's also known as the power set, which is the set of all subsets of a set. Okay. We're finally ready to assign probabilities to events. So I know I was talking about how this is going to be probability, but we've just talked about sets mostly and events. But now we're ready to talk about probability. So we define the probability measure, which we'll typically refer to just as probability. The probability measure to be a function from this event class. So it takes an event and it gives you a value between 0 and 1. Okay? So it's a function satisfying the following conditions. For every event, the probability measure of the event is greater than 0. So if it's an event in the event class, it has to there has to be some chance of it happening. Otherwise, it doesn't belong in the event class because the event class is only for things that could happen. So, for instance, in Dumb and Dumber, when he's like, "You're saying there's a chance," he's really asking, so you're saying that this belongs in the event class, which is true. Okay. In other words, the probability of the event is greater than or equal to 0. If an event, oh wait, no, not equal.
Not equal to. That would make no sense.
Probability of A is greater than 0. If an event is the entire sample space, its probability measure is unity. In other words, if A is all the possibilities, then the probability of it happening is 1. In other words, your event class is exhaustive. It covers everything. There's not something else that's possible. If you've covered all your bases. If events A1, A2 are disjoint sets, which means there are no elements in common, then if you want to know the probability of A union, A1 union A2, etc., then all you have to do is sum up the probability of each of them. It only works if they're disjoint because otherwise you end up with a probability greater than 1. You can't have that. Okay, the 3 structures we've defined thus far, omega, sample space, F, event class, and P, probability measure, are called the probability space, which we denote omega F P. We conclude with the basics of observing 4 facts can be proven from the definitions above. So, the probability measure of the empty set, which I'm going to do a little more sideways with that. Probability of the empty set. What do you guys think it's going to be? 0. Okay. What is the probability of A union B? So I'm going to write it out in terms of the probability of A plus the probability of B. And there's going to be a correction term here. What should that correction term be?
Minus the probability of A, whatever B.
Yeah, intersect B.
Intersection.
Because otherwise you're counting it twice, right? So it's like we did a Venn diagram. We were like, sum these up, and you added them together, but you double counted this intersecting part. So you had to subtract out the intersecting part, one of them, so that you got just one count of it. All right, so that one's cool. If B is a subset of A, then the probability of B is less than the probability of A. In fact, the probability of A minus B is equal to the probability of A minus the probability of B. So this is a strict subset, right? What do we call it? A proper subset. So that means that A has more possibility, and there are more potential events or potential outcomes that could that are in A. Therefore, it has to have a greater probability. So, yeah. Okay, if this is the last one, the probability of events A1 union A2 union, continue on. You know how I said if at the beginning? I was reading from the previous line. So probability of the union of all of these things is less than or equal to the probability of each of them separately added together. So if they're disjoint, then we have equality, right? But if there is any intersection among them, then it's less than. Okay? This is a little bit like the triangle inequality you guys might have encountered other places. Okay, so that's basic probability theory, and then I want to kind of give you like a little bit of, because we only have a few more minutes, so I just want to talk about where we're headed, I guess. There's probability underlies like the discussion of random variables that we're going to have and all that and the statistics that we're going to discuss. And I know that sometimes like these little like toy problems with like rolling dice and all that are kind of like they don't feel very real. But we use these sorts of toy problems to get the idea down of these concepts. And they are actually really applicable to like real measurements. And on Friday, you guys will be getting your project, or not project, but your midterm, take-home midterm exams that are going to be applying the stuff that we've learned to real measurement system and or measurement systems. I haven't quite decided if it's going to be multiple, but I think I'm just going to do one. And well, I'm not going to include the probability stuff on there yet because we haven't gotten far enough in it. But I am considering making your either your project an extension of this or your final exam an extension of this, where you apply the other techniques to a measurement system as well. So we're going to use these things on real problems, and we're going to see how. But understanding the foundation of it and how all of the pieces fit together at this level is important. So, are there any questions on basic probability stuff before we move on? Okay, there's a homework assignment. Doesn't. It's actually a super fun one. Have you guys seen it?
I've tried it.
Yeah?
Tried it.
You got about as far as he got.
So do you guys remember we did it in class, right? We did one. The square wave one. So it's essentially the same analysis that we did in class. It does kind of suck because you do have to write like a program to do it, but it's with a different waveform. And instead of varying the damping ratio, which is what we did in the class, you're going to be varying the natural frequency. And that is just, I mean, it's actually similar to how we varied what did we vary? Oh, we varied the frequency of the signal that we were measuring, right? In the class example. But we're going to keep that the same in this homework problem. We're just going to vary the natural frequency of the problem, of the measurement system. So we're going to see similar things emerge. Like there's going to be, for one of the frequencies, it's not going to be very good because it's too underdamped, and we're going to see these higher harmonics coming in. Well, actually, no, it's not. We're going to see the effect of, I guess, the phase nonlinearity coming in. We're going to see some distortion. And then the other one's going to respond super slowly because it's like way overdamped. Or no, wait, no. Oh yeah, no, that one is, it's going to respond slowly because the natural frequency is low. That's why. It's going to respond slowly. And then the other one is going to respond like, okay. So that's the idea, is that you're going to be able to see the effects of the distortion. I realize that sometimes it's just like the programming is the problem, and that sucks. I don't really have a good answer for that, other than like we all have to do we all have to go through this, and it never is fun. You guys might think that like I woke up one day and like knew how to program. Just did not happen. My wife will attest, because we were dating in college, to the fact that I was not a fan of MATLAB for quite some time. So like I feel your pain. Like I was there and I was like, this sucks. Why is this useful? Eventually I bought onto the program, and like now I actually really like it. So it's not always such a thrash, but for a while it really is. I'm happy to, so with programming questions, asking me on Slack is a pretty good way to go, because you can paste code into Slack. You can also put like your M file from your MATLAB code like in there, and I can just like run it, and I can try to respond. If you post stuff to the main homework thing, that's fine too, because this is homework, and I want you guys to collaborate and help each other. So if you post it to the main homework channel, and like people are like posting snippets of code of like, this is how I'm doing this, like I'm having trouble with that, how did you do this? That's all fine. I encourage that. So help each other. I'll try to help too, and we'll get through it together. Okay. Are you guys playing any rugby matches?
Not this year.
Not this year, so you're just like getting the team.
Katie said the earliest we would play would most likely be next semester.
Wow.
But that's really iffy, and mainly because we need to get more numbers. But like for sure would be next year.
That's cool. Is your guys' plan to become like a varsity sport then? That's cool.
Well,
That's
what
cool.
kind of sucks is the NCAA doesn't recognize rugby, which
Oh.
kind of doesn't suck because we don't have to follow that
Oh yeah.
girls for guys kind of rule where they can't really
Title IX.
Everyone. You don't have to have equally matching sets of sports.
And we also
Yeah.
get money from clubs.
Yeah.
For being a club. So.
Cool. Nice. Well,
So
good
if you
luck
want
to
come
you.
Join. Fraser faculty is open to it too.
Yeah, I used to play football a long time ago. I'm more of a I liked baseball and basketball better than football. I don't love the contact. It's just not I'm just not a huge fan.
Everyone has the things they like.
Yeah. I know that it maybe surprises you that I don't but I was a running back for a while, and I was like, I don't really like this that much. Pretty much you just get smashed on every play. And then I was a wide receiver, which was better. And I was a defensive. Then I was a free safety, and then I was having to hit people really hard all the time, and I was like, this is painful because it's cold. Yeah, but I wasn't good at that. They wanted to make me a quarterback, but I wasn't that good at that either. So.
This is why you had to go to MATLAB.
Yeah, that's right. I was much better at baseball than the other ones, but basketball was my favorite to play.
Why don't you ever come play with us, man?
Basketball?
Yeah, we usually play at noon.
Yeah, I would like to. I also think after you're 30,
There's no excuse.
There's a
Yeah, but
real-
until he was 55.
yes, I mean it's true, but so
Yeah,
my
yeah.
wife manages a physical therapy clinic, and a really common injury for guys is playing basketball, and then it's a pretty gross injury. Their Achilles tendons tear off of their heel. That's
You can't be thinking about
horrible. That would suck so bad. I would really hate that. Or blow out a knee, and have to get ACL.
technology.
You could have a titanium. I think your program with MATLAB.
We also the
I know those old guys who were getting cortisone injections to play softball, and I'm not gonna be like that. That's too intense for me. I know a guy who was he could hardly walk around. He would go get cortisone shots so he could go play softball every year at this thing in Vegas, and I was like, you could just go to Vegas,
if you ever get the chance to go on McCord around 3 or 4 o'clock
Mhm.
on a Tuesday, there's this old guy. I swear to God, he is 60, 8 or 9, on the verge of being 70, and he plays basketball with us young bucks. Granted, he doesn't do well on defense, but he never misses a shot either.
Wow.
He pisses us all off.
Oh yeah.
So
If you're blind, you miss them.
Just check him
he
real
has
hard
better
one
vision
day.
than I do. So
Horrible vision. My glasses fall off. That's game over. My coach literally told me you should this wax stuff called cat crap.
or you just get the goggles.
And put it on, and then he shows me one day. Stuff smelled so bad. It's so bad. And he put on my glasses one day because they were just bad. I couldn't see it all. I threw up mid game. It got so bad.
I don't think that's the correct way of doing that. That doesn't sound right.
I asked your coach, "Did I take off my glasses?" He's like, "No, you can't see jack. You're just gonna miss." And